Fantastic. All right. Happy Monday, everybody. Today, we are going to be going over unit testing. I hope everyone had a great weekend and everyone got just got some rest and relaxation and recovered from our long conversation from last class about a bunch of other stuff. This is not that stuff. Okay, good. Sorry, I almost don't get situated here. Perfect. So, yes, today we're going to be going over unit testing in Java specifically. So we're going to be kind of doing exactly what we did in JavaScript, but we're going to be, of course, transitioning it into Java and using our Java knowledge to make those tests. So, but before we get into any of that, I promise we're not going to dive right into unit testing. A few announcements. One, remember that assignment 1 is due. It was due last week. Make sure you get those in. You're asking questions, you're getting it done. If you ever do have any knowledge gaps or just any kind of blockers whatsoever, reach out to your TAs, reach out to fellow students, reach out to me, and get that assignment in as soon as possible. You don't want to have assignment 1 on your back while assignment 2 is coming right around the corner. Next up, remember, if you do need any help with that assignment or anything in general, one-on-one help is available on Calendarly, however you say it. The link is in our announcements. If you need the link, of course, reach out to me directly. Happy to meet with you one-on-one to go over any concepts, concerns, questions that you have that would really help you out in Java. Then finally, you guys have found the studios, you found the lectures, you found the exercises, but if you need the slides for whatever reason, the slides are on Google Drive. Just a quick reminder of that. So if there are no questions on that, without further ado, we're going to begin class. Again, we're not going to hop right into unit testing today. Instead, I want to go back to a previous question that we talked about last week that just seems to keep bubbling up with better and better questions. So previously, I believe it was Alexis that was asking, how much room does a variable take up? Well, we're going to work through this. Remember, this is just a side note. You don't need to remember this. This isn't going to be on any test anywhere. It's not going to be like a necessity in your Java skills. It's kind of just a neat question that was asked in class that if you want to know the answer, here's the answer. Before we talk about how much does a variable take up, let's get a real quick reminder about these nulls. That's where this question stemmed from. If we have a string and an integer, my string, my integer, both set to null, the question was, how much do these take up if it's just set to null, which is basically nothing. As we said in our memory neighborhood, my string and my number are both housed at the same location. So they both take up only a single null. A single null takes up 8 to 16 bytes. So this is what our answer was last time. To continue on that, what are these red arrows mean? And what concern do they play in a variable? Well, remember, a variable is just something that points to a memory location. In this case, it points to the address 01. But it's the space that it takes to remember where it's pointing to, called a pointer, that takes up the space. To remember where it's actually pointing to takes up more space. It takes up 32 to 64 bits. So that's how much space a variable takes up without even being assigned to anything. So I believe the question was proposed, what if we had 1,000,000 variables? Well, we do 1,000,000 times 64 bits plus, and again, we're doing worst case scenario because as a programmer, it's always great to plan for the worst case scenario, plus 16 bits. So we're taking the far end on all of those. What that equals is 8.00002 megabytes. So a giant application with just 1,000,000 variables set to null would take up about 12.5% of storage capacity on a typical N64. So that exactly is how much space a variable takes up. And if we had 1,000,000 variables, that's how much space it would take up. Any questions about this? Any comments? Any concerns? If anyone has to ask, yes, I did have to look up how much an N64 actually storage is in there. I got an N64, my personal Christmas present to myself, and I've been addicted to it quite often. Mario Kart is the bomb. Whew. Everyone's being really quiet right now. Must be Monday. No questions, no comments, not even a snicker. Okay. Almost hurts. Maybe I disconnected. Can anyone actually hear me?
Yeah.
Hello.
Okay, thank
All
you. I'll
good,
take
Kyle.
it. Thank you, Sandy. Thank you. Somebody cares. Wow.
Wait,
Jeez. Okay.
How much memory is in a Nintendo 64 in total? I'm trying to.
64 megabytes was the high-end classy version. Right? I was like, okay, that's not a lot. And you could increase it by 12 kilobytes by those little injector things that they have on the front of it. It's like, yeah, that was my Sunday right there. In case anyone's wondering what I did on Sunday, a lot of Wikipedia with N64. All right, let's move on here. Let's move into something that we were talking about last week here. I know we didn't really start off on a good foot last week after our break. I don't think a lot of people will have to be very happy with me. So I'm going to bring it back, try to do this more with a smile. Everyone's relaxed now. Let's try to talk about what we talked about last week. Say we want to create a class variable for a social security number. Now remember, the social security number will never change because a person is assigned a social security number, and that human class or that person class, it should never change once it's been assigned. So tell me, how would we create this class variable?
Public static.
So it would be a class variable, so we have to do it as private.
Oh, private.
Final, very good, because we want it to be constant. We don't want it to ever change, so it's private final. And then we're going to have a social security number as a string because it has dashes inside of it. So remember, if it's not going to change, it will be final. One more, if we create a final method variable, that's a variable within a method, for the year, how do we do that? What would we start with? A final method variable. What's the keyword that we start with?
Public.
Static.
So if it's a final method variable, it won't ever have a public or private accessor because it's within a method. Inside methods, we don't need to
start with final.
Say that again.
I was going to say, can't we start with final since final is an accessor?
You would actually start with final. Final is
Okay.
more of a modifier to that variable. It's almost an accessor. It's basically a keyword that says this thing is never going to change. And then we say what our variable is. In this case, it's int year 2020. Furthermore, I said it's a method variable, so this would be wrapped in a method. This is how it would look inside of a method. And I only wish there was a taxes class that you can just do this, but unfortunately there is not. And don't forget, everybody, it's taxes season, unfortunately. I found that out today. I was like, I started getting things in the mail. I was like, oh gosh, I have to be an adult. All right. So in overall, what we're talking about here is final. Remember that it keeps a variable constant. Keeps a variable constant. It does not change. That's what final does. The keywords like const and constant that you would see in other programming languages, such as JavaScript, they don't exist in Java. That translation is final. And I want to make sure that that is very much rooted ingrained in our memories as we move forward. Const and constant do not exist in Java. Final does. Any questions about this? Okay, we will move on. So let's talk about something else now. We're going to kind of describe what these variables look like in different scenarios. If I was to create a dog object called my dog equals new dog with Stark in there, we've seen this before. And I call to my dog.get my dog's name and return Stark. What would we expect this variable to look like in the dog class? What would it start with?
Private string.
Private, very good. And then string, awesome. It's private string, my dog's name equals Stark. This is exactly how it would look in the dog class. We know this because we did a getter, my dog.get my dog's name. The hint was the class variable's name is my dog's name because that's what's in after the word get. It's a class variable, so we know it's private. And it's a name, so we know it's a string. That's how we could put this together to figure out what this variable actually looks like. Let's move forward. If I have another variable here, dog.diet type, and returns omnivore. Also found this out, mind blower, dogs are omnivores. What would this variable look like in the dog class?
Static.
Public
Very
string.
good.
Public string.
Public, it goes public. We all have that right, very good.
Static.
Static, fantastic. And then string. Public static string diet type equals omnivore. How we access diet type is a clear indication that this was static. Looking a little bit more at it, static allows us to directly access from the class. Static variables do not let us access from the instance. This is what static does. So looking at this, does anyone have any questions about static and or final? Anything at all? All right, we'll move on. So we don't have any questions about static or final. It's time to move into it. We're going to talk about testing. But before we even actually look at any code or anything, have you ever asked yourself, why do we do this to ourselves? Why do we actually test something? Why do I have to, after I write my beautiful code, go back and prove that it works? After I just proved that it works by running my application. What's going on, and do I even get paid enough to do this? Well, the answer is no, we never get paid enough. But why we actually do it is, the first thing is to save us from a bad case of the Mondays. If we are writing code on Friday or on Thursday and we are having a long week and we don't exactly remember what we truly wrote when we come through those doors on Monday and we start writing our new function or a new method that our boss wants us to write, we could easily break our code if this application is gigantic. Those unit tests are there to protect us on Monday, that when we create new code on Monday, we didn't break anything that we did on Friday, hence giving us a worse Monday. That's why we first test in Java, or that's why we do testing in any language. Second, it saves us from others having a bad day. If you're working in a team, which is a typical architecture in any corporate atmosphere, you're working with 4 other developers, they could be having a bad case of the Mondays on a Thursday. And if they're having a bad day and you're not testing your code, you have a bad day. Because once you pull from their code using GitHub and you pull a bug because we didn't write a test around it, that means it's on you now too to find where this bug is. Bugs can be contagious very easily if you're working in a team environment. That's why tests are there. And then finally, it's to save us from ourselves. Just like Mondays, and just like when we're writing over a 3-month span or 2 years, we're not going to remember everything we did. That application we've been building on for years because we want to keep enhancing our knowledge, if we're not writing tests around it, we can easily introduce a bug somewhere else in our code by just putting a simple method that we thought would really enhance our application. So this saves us from our past selves. Where did I have that wrong? I think it saves us from our future selves. It saves us from our future selves. Yeah, there we go. How do I think of that? It saves us from our future selves, essentially. So this is why we test, to save our time and to know that when we code something, it has integrity. So hopefully I sold this to you, because I kind of sold it to myself. I really don't like testing. I know we have to do it. It's like it's a necessary evil kind of thing, but I hope I sold this to you guys as well. Any questions about that? Alrighty. Then now we should all be asking ourselves, how do we actually do this thing? Well, let's talk about it. We're going to go back to that TDD acronym, test-driven development. We should all remember test-driven development from JavaScript, but we not know specifically or remember exactly what it actually means to us. So let's just remind ourselves. Say we wanted to develop a new cat class. Well, we already have our dog class, but we don't have a cat class. So let's start setting this up. With TDD, the first step is to actually write the test for the cat. Before we even create that cat class, we need to essentially put out what we want this cat class to do. I'm gonna wanna test, does the cat have a name? Does the cat have an age? Does the cat meow? These are things I wanna test for in my cat class that should work when I'm all said and done with my cat class. So what TDD does, it helps us create a checklist of what to do when we're developing our brand new class or our brand new feature. So if we all ran these right now, and of course it would fail because there's not even a cat class. Oh, that's gonna be bad. There's not even a cat class involved. So again, the second step with TDD is that once you write the test, you start developing the class, in this case, the cat class. And as you actually write the code, it will continuously start passing those tests. So as you write these tests, you should get less, or as you write this cat class, you should get less and less failing tests until the very end, all of your to-do lists or all of your tests are passing. This is the essence, the bare basics of TDD and why we do it. Any questions about this? I'm gonna have to send coffee to each and every one of you, aren't I? I just gotta wake up. It's a happy day. It's a gloomy, gloomy, gloomy day. I know, it's a gloomy day. It's a Monday. It's gloomy.
I'll take hot chocolate.
Exactly. Everyone's homework is go get some sugar. Do something. Oh. All right. Fine. I'll be the peppy one here. All right. This is TDD. I hope everyone likes it. I know sometimes there's a hit or miss on this one, but this is why we do it, and it does really help you out when you're just trying to keep track of exactly what to do. So, as TDD is spoken here, let's take a look at the first test if we wanted to actually do this. So, does the cat have a name? Just taking a look at the first test case. Let's translate this to actually what it means. Does the cat have a name? AKA, does the class variable name get set properly within this cat class? Now, see this translation between what we're actually asking and what we want to actually build now. So let's start doing this. Hypothetically, we're going to build our cat class here. Cat, my cat equals new cat, Bella. Bella will be our cat's name. So Bella is the actual name of the cat that we're setting in the constructor. Therefore, when I get my cat's name back, it should return Bella. So this was two things I just said here. Bella is what should be there, what I expect to be there, which is going to be hard-coded in our test. We always hard-code our expected values. And then I should be getting back Bella, but I need to actually get back what actually comes back from the method. Therefore, I get back the actual from the method itself. This is the actual value, what actually happened in reality. Not everything we expect is in reality. Reality produces, I have Monday brain too. I'm gonna just quit that analogy right there. So that's what we have here, is that we have our expected value, which is hard-coded as Bella, and our actual value, which is getting the value back from get my cat's name. So what we have to do is check, is expected equal to actual? That's what we typically do in tests. And how we do that in JUnit is that assert equals. In assert equals, we have the first value, which is expected, and the second one, which is our actual value. Assert equals will check if these two are truly equal. So that's how we would set up this test. Furthermore, we of course have to wrap it in something. In this case, it's our testing method, which should always be public void. Tests written in JUnit should always be public void and then the name of our method, or then the name of our test. The name of the test should be something at least describing what the test is doing. So this is left more to the programmer and also your team's standards of how you want to actually write names of tests. There's plenty of standards out there of how to do it. I particularly just try to go with the best description possible. One last thing. For tests in JUnit, we need to add the @ then test. You've seen something like this before in our last class. This is called an annotation. We're annotating our tests here. So with this annotation, when we actually run our method, or sorry, when we actually run our class full of tests, our compiler knows their tests and run them accordingly. So does anyone have any questions about this setup of just a straightforward test like this?
So the annotation, I thought it was just like a comment pretty much to let others know it's a test. That actually does something, so that's necessary to have it before all tests.
Absolutely, yes. An annotation is more for the compiler than for a human. We know this because override that we looked at in last lecture for toStrings and equals, it tells the compiler we're overriding it. Remember, to override, we do @, then override. That's another annotation. This one is our testing annotation. So yeah, to answer your question, yes, it definitely is for the compiler more than for the human. Great question. Anybody else? All right, in that case, we're gonna implement this. Let's get to it. We're gonna open, if my computer wants to work with me today. Where's that exercise project? There we go, open that up. Alrighty. Okay, so this is our exercise project we've been dealing with the whole time. Nothing here has changed, except for now I have an error somewhere, so that's changed. Oh, what is that? All right. So first things first, we're going to be writing a test. Things that you've seen in JUnit, or things you've seen now in IntelliJ, is that you might have seen that lib folder there. So we're going to go ahead and add one of those. Just call it lib. What I'm going to do here, oh, I'm going to have to, dang it. I'm going to have to set that up. I'm going to grab these two jar files, copy them, bring them over here, and I'm going to paste them in there. There we go. Now we have that Hamcrest core and that JUnit in there. Kind of what you've seen in your past. I'm sorry?
I'm sorry to interrupt. Can you do that one more time? Show me how you got that directory to pop up.
What part
click on example project?
Oh, so what I did is I pressed new and I clicked directory.
Oh, okay. Thanks.
Yep. So I completely created it custom right now. So yeah, click directory. I typed in lib, and then I created the lib folder, and then I just copied from my desktop these two jars from our car test example and just paste them in there. So we have them in this project. Alrighty. So what I'm going to do here is that I'm going to right click on it and just say add as library. Say okay. And same with this one. Fingers crossed that IntelliJ is not going to make me look like a fool. Second package. And what I'm going to do down here is create two different packages in here. First one is going to be main, where we've seen all of our typical classes, things that we aren't writing tests in. That's what main has. It's things that we aren't writing tests in. It's things that will be tested. The second directory we have, or the second package we have, is the test package. So we have main, which holds all of our classes that are to be tested, and tests hold everything that will test those classes. In this case, we need to create a new Java class and call it cat test. And here, I'm going to now create that test. And I say public void, and let me get my slides up here. This will be way nicer now. There we go. Public void, because tests are always public void, and then cat's name gets set. And as we said in here, we write this, but we know we're going to get errors. We know we're going to get failing tests. Things are not going to look pretty in here. And unfortunately, this is TDD. So it's okay to see red. So what we said is cat, and we're going to call it my cat equals new cat, and then Bella. Then we said we had to get our expected string, which string expected is going to be Bella. And then our string actual is going to be my cat dot get my cat's name. And then what's our last thing we need to do?
Assert equals.
Third.
Assert equals is actually just one method name now. I know it's a
Okay.
little different than what we were doing, but it's just assert equals now. And then what's our first parameter inside of assert equals?
Expected.
Very good. And then it's actual. Fantastic. Okay, assert equals is always a tricky one to get a hold of, and I always forget where it's saved. Anybody remember where the import for that one is? Oh gosh. Anybody remember where that is being imported from? Sometimes IntelliJ doesn't let you.
I think it is capital A, starts with capital A.
Like that?
Yep. Yep.
Mine is assert dot star.
Oh, okay. I see what you're saying. Okay. Oh, the star. Okay. Thank you very much. It's static. I apologize here for this.
Why doesn't it import it for you?
This one, because assert equals is actually a static method. And for some reason, JUnit will mess up on those static methods inside of packages or inside of jars.
Put it in Slack.
You did, thank you.
Mine also has import static for JUnit assert dot star.
Yeah. Okay, yeah, thank you very much. And just for good measure, we'll put star there. In case anyone's wondering what the star does between star and putting assert equals there, a star will just take in the entire array of packages from the assert package instead of just one specifically, which was assert equals in that matter. Okay, let me get that going. All right, so we have our first test written. Our second test we wanted to write was, does the cat have an age? And so what I'm going to do here is create another test that gets cat's age. Age gets set, my cat, and of course I'm going to put the age behind it. It's going to be 7. And so the expected should be 7 at this point, and I should, oh, that is an int. And then my int actual should be get my cat's age. So this is how we'd be writing a integer test for how does a cat get an age. So the final one is, does the cat meow? And it's going to be called cat returns meow. So what this is going to be a method we need to write that returns meow from a method. So can someone tell me how we start writing this test? How can we edit the test I pasted down here to write something for this? First things first, from the description of having to return a meow, what should our expected be?
String.
Very good. What should be the expected value of that string?
Meow.
Awesome. Now we're on to actual here. What should we do to edit this to make it ready?
String actual.
Very good. Then someone give me a name for the method that we're going to create here. It can be literally anything. It's up to your creativity.
Garfield.
Cat returns.
Someone say that again?
Garfield.
Oh gosh, Garfield. Is that how you spell
Cat that
Garfield?
hates Mondays.
There you go. Is that how you spell Garfield? Anybody?
That's right.
Okay. I'm gonna say Garfield meows, just to give it a little bit more description there. So Garfield meows. All right, and then we always assert equals that expected to that actual. All right, so from this implementation, any questions? I know we're getting some red here, so I know sometimes that can send cringes down our back, but we're gonna get rid of them next. Anything at all? All right. So what we're gonna do now is, well, I'm sorry, what is our next step? Who can tell me step number 2 with this, or TDD? What's our second step? We created all of our tests. Now what do we need to do?
Create those functions, methods.
Create the class. The class.
Very good. We have to create the class, but then you're also right. We have to create those methods within the class. So tell me, what package should we create our brand new cat class? What package? Main, very good. Because remember, main is where we put all of the classes that are to be tested. We call it cat. All right. First things first, what goes at the top?
Main.
So remember, in classes, we actually won't have mains typically.
Public static void main.
So we won't actually put a main in this class. Mains are, we'll talk about this tonight a little bit too, but main will exactly be first in this test, or in this class. But what do we know? What is always the first thing out of 3 things in a class we always put at the top?
Class variables. Class variables.
Very good. So who can tell me one of the 2 class variables that we need for this cat?
Name.
Stat.
Name. And how do we start writing that?
Public static.
Private.
Be private, very good.
Yeah.
We're not going to create this static. I promise, I'll give you strong hints if it's going to be static. We're typically not going to write our class variables as static most of the time. But names will always change depending on your cat. You're going to have cats of multiple different names. So that's the biggest hint that it's not going to be static. So private string, very good. And then I think you already said it, name.
Name.
Perfect. And I'm not going to set this to anything because I want to be able to customize it. So I'm going to put this in my constructor here in a few minutes. What's the second class variable that we need for these tests?
Private int age.
Very good. All right. So first things first, like I said in TDD, we need to just write tests to start at the top and work our way down. So we're just going to focus right now on making this test pass. This test, who can tell me what this test tests specifically?
The name.
The name, very good. And the constructor looks like what exactly? What do we take into the constructor?
String.
String, very good.
Okay.
So the next thing we always put after a class variable is a constructor. How can we make this constructor look like what we saw in our cat tests to make it pass? In another word, what? Oh yeah, go ahead. Yeah, perfect. Public.
Cat.
Cat, very
And
good with a
parent.
capital C.
Yep. Parentheses. Yep.
And then what should go inside the parenthesis?
String name.
String name int age.
Very good, everybody. There we go. And then how do we set our class variable to whatever's being passed in as a parameter?
Dot name equals dot name.
Yes.
So we start with this. Very good. The keyword this to access our class variable.
Name equal name.
Very good. Awesome. All right. So we have our Bella class written here, but what's one more thing? Oh, let me go ahead and start fixing this import class. Oh, hope I like a big weight got lifted off everyone's shoulders there. I want you to see a lot of red gone. What's the new thing in red now inside of this test specifically?
Getter and setter.
The method.
The method, very good, and I heard the getter. So the getter is here. So let's go ahead into our cat class, and how can I create a getter? What do I start with to create a getter for my name?
Public.
Perfect. What's next?
Void.
String.
String, because
A string,
remember, getters get information. So we're gonna have to have a return type. In this case, a name is a string. So the return type is string. And then what do we call it?
Get my cats.
Well, in this case, we'll call it get
Get
name
Yeah, get.
because our class variable's name is name. And then we return this dot name because we're accessing our class variable through the this keyword. You might also see getters with just return name. Auto-magically, this is included in this, but I like to put this there so I know it's there. So you might see the differences there, but that's why. This is technically there. It's just invisible if you write it that way. So.
Just want to keep an eye on. Okay.
Okay, so we have our getter. So in the cat test, what happened here is that we're still getting red here because we didn't actually fully develop how we wanted to do the cat class to how we did the test class, which is completely fine in TDD. Remember, this is just a set of guidelines, a to-do list of how to do these tasks. We don't have to do them exactly how we do write the test, how we write the test. So I can just change this to get name now to get rid of that red. Oh, I did something wrong. There we go. Okay. What do I need? Okay, just that one. Sorry, I did a mind blip right there. This is for the cat's age, and this is for the for Garfield meows. So we won't be changing those. We'll only be changing the one up here that was red. So perfect. Now that we have this test passing, but we do have red in here. So like we talked about in the very beginning of class, I don't believe Java is going to be very happy with this. So let's take a quick look. Yeah, it's not going to be happy. We can't run these tests with it in there. So what I'm going to do is kind of just cheat just a bit. And don't tell my mom. I'm going to cheat here just a little bit. Put that there. Perfect. So I just want to test out this one test to make sure it's working right. Let's see. Awesome. Okay, we got one test passing. Like air high five, everybody. We got that test passing. Oh, that actually is a big weight off my shoulders because JUnit has not been kind to me lately for some reason in the last two examples. So any questions about this? We got our test working. Our first one's done. We have 2 more to do, and then we're done with this cat class. Any questions? Okay, so let's move on. We're going to do the next test. Get my cat's age. I'm going to leave that one commented out because we're not going to get to that just yet. We go over to cat. So what do we need to add here so we can get or set our cat's age within this class? What do we need to do?
One more constructor.
Another constructor.
Very good. We need to add another constructor here. What is that called when we add 2 constructors?
Overload.
Overloading. Very good. All right. So what do we need to put in here?
Int age.
Fantastic. And I'll do this last part for us. Equals age. Awesome. So there we go. We have another constructor in there now. Let's go back to our test and see what else we need to do. Okay, this is red now. So get my cat's age. What do we need to do in our cat class? What is it? Sorry, my headphones went out there for a second. What do we need to add?
Set for age.
Public int.
The getter. Very good. Public int get age. Fantastic. And we change this to get age. All right, run it. Fingers crossed. And we have our test passing. So we have this test passing now, but we changed stuff in our code. So we don't exactly know if this individual test passed too. So after you create a new test, the a good practice is to come up to the very top and run all of them now as you work your way through your tests. So now we see that we have 2 passing tests. Perfect, we're good to move on. Final thing, we need to see if Garfield meows. So what this has to do is just return back meow. So I'm gonna go ahead and create that now. We put our other methods down here. So I'm gonna say public
String.
Very good, public string, and then the name of our method, which is Garfield meows, which I love. Garfield meows. All right, there we go. Garfield meows. We come back to cat tests. Everything's good there. Let's run it. Cool. All right, everybody. We have that test passing, and now we're gonna run this one. And we now have 3 passing tests. There you go. Mark it done. Our Monday is a success. We have all our passing tests. So great job. As always, questions. Anybody have any questions about this? We just created 3 tests here. JUnit might be a little new to us. Any confusion at all? Any questions about why we did something that way? We also did this in TDD, so there was a process there that we might not always do. Anything along those lines?
I have one question.
Yeah, what's up?
Okay, so can we create one constructor for all 3 for both the variables, cat, name, and age? Or does it need to be 2 constructors?
No, so we could definitely, since we didn't do anything with this one, we could just put 7 in here. And then we could just totally remove this other constructor up here if we wanted to.
Oh,
We're just
okay.
designing this cat class, so this is how we designed it. And again, of course, sorry about the ambulances that come by once in a while. St. Louis likes to burn down here and there. But does that answer your question, Hawa?
Yes, so I think since we are testing name and age separately, so that's why we need to create the 2 constructor. Am I right? Or
Yeah, absolutely. So we could design our constructors here differently if we wanted to just take an age or just take a name. But the typical standard is what you see here. We kind of add on to our constructors. So the first one is just one parameter that has name, and then the one that we overload it with takes a name and age. This is the typical standard you'll see in most Java classes, is that we're kind of adding on to it in complexity as we move down our constructors.
oh,
But to your point as well, we can just create these constructors taking exactly what we want, which is completely fine. It isn't completely up to the typical Java standard. So it's whatever you want to do in your own project. This is completely fine. I'm just showing you exactly how I would approach the problem.
right. Okay, so if we comment out the first constructor, does it still pass the test? Because we already have name and age in one constructor.
Say that one more time, the first part of that question.
Okay, if we comment out the first constructor, like the one who is having name, does it pass the test or not?
Well, so if I took out 7 here, that would technically break it because we no longer have a constructor that's just taking in the name. I would have to add 7 to the end of this. But once I do that, absolutely all of our tests will pass.
All right. Okay, I got it. Thank you.
Absolutely. Any other questions?
When you used the Garfield meow, how come you didn't have to use a get for the sound that the cat makes?
That's because meow down here isn't a class variable. I didn't want to make it a class variable.
Okay.
Yeah, it was more on personal design and preference. Names, ages, social security numbers, significant things like that, I would want to make into class variables. If I wanted to, I could put up here private string cat sound, something like that, and type that one as meow. And then pass that into a variable, or pass that out here if I wanted to. That's cat sound. So that would be one way we could remove meow and put it in as a class variable. But I personally didn't find meow significant enough to make it a class variable.
Okay.
Yeah, absolutely. Great question. Great questions. Thank you for asking questions. You guys had your coffee. Anybody else? Anyone else got questions? Curtis, what's going on?
I'll try to describe. So the textbook often puts the expected right in the actual unexpected rather than creating its own variable. Do you have a pro or con for making a separate variable instead?
No, you can absolutely just directly inject it if you wanted to. I did it from the example of our PowerPoint to kind of bleed into what we were doing on the tests, but that's absolutely fine. If you wanted to, go ahead and put in Bella right directly in there. When I would say don't do this is if you have a very complex expected value. So what is a complex expected value? Think of maybe, I don't know, from assignment 1, an array of hash maps. That would be a very complex thing to make into the assert equals. So if it's simplistic, like a string or just an integer, like we did in these examples, go for it.
Thanks.
Yeah, absolutely. Anything else? All this again. Sorry, everyone gets a refresher. Click the wrong slide. There we go. All right, let's move on to this now. Let me get my Slack open. There we go. So let's just make sure we got everything that I just yabbered on about. First things first, asking you this, an annotation always begins with the blank symbol. What symbol does an annotation typically start?
At the rate.
At
Very good. The @ sign. The @ sign. So that A with the squiggle in it. That's what I always refer to it as. I know some people refer to these symbols as something different, but the @ sign. So there we go, which was first included in emails before it was all about the Twitter stuff. All right, and the second question is, and goes blank the method. Where does it go on the method, these annotations?
Above.
Very good, above it. Always above the method. Directly above it though. There cannot be spaces between @test and your public void. There can't be another enter. Make sure they're together. They need to travel in a pact. @test doesn't like to be alone. All right, the next one is a test method always has the accessor what? What's an
Public.
accessor? Public. Remember, accessors are public, private, protected. Test methods will have public. And the return type will always be what?
Void.
Void.
Very good. Void. A variable that stays constant will always have the blank keyword.
Final.
Very good. Final.
Final.
Awesome. All right. How's everyone feeling? Everyone feeling pretty good? You feline sharp? Everyone, take a second, take a breath. Feel free to, right? Dad jokes all the time. Love them. At this time, type in any questions that you have about anything you want to cover that we've covered in this lecture. So express that again. Message me directly if you don't want to ask it on the channel. But try to ask any questions. But if you don't ask any questions, then answer a few questions of mine. What is a group of kittens called? Is it a cluster, a kindle, a binding, or too cute to handle?
Cluster. Is it cluster?
Kindle.
Too cute to handle.
Too cute to handle? That is always correct. Anybody else got a last minute guess? Because it is Kindle. Very good. All right. Cats can jump up to 4 times their height, 6 times their height, or 8 times their height.
8
Believe it or
times.
not,
8 times.
8 times.
8 times.
Too cute to handle.
Always right. It's actually 6 times their height.
Oh.
It's 6 times their height, which is still pretty high.
I was just wondering if the Kindle Fire had like a different meaning to it now.
Ooh. Catfire. Oh, catfire. That's terrible. That's a good question. It's probably on Wikipedia. I should know that. All right. How many toes does a cat have? Is it
4.
14, 18, or 20?
Oh, all together.
18.
It's 18.
Wow. Okay. This is the one that really caught me by surprise, but everyone knows. Okay. It is 18.
I clip my cat's nails.
So you know. Awesome. All right. Well, enough with the cat facts and also the dad jokes. Let's move back into setting up tests. All right. So we talked about tests, how to set them up and everything. And what we got was basically 3 different tests, all of those annotations, which these kind of look similar to what we were doing. And one thing you might have noticed is that they all have these constructors inside of them. We build a new cat every time we want to test. This, again, programmers are extremely lazy. I'm offending myself here because we don't like to write a lot of code. We want to get to the point as quickly as possible. So what we would like to do is consolidate some of this work, especially in tests. So the question you might be asking is, how can we take out these 3 lines of code and maybe consolidate it all into one? And the answer is by utilizing this before tag. What this does is that we could build a cat once before every test is ran, all using this beautiful annotation at before. That's how we can build our class, the cat class, one time on one line of code instead of having to do it 3 times on 3 different tests. So let's see this in action. Going back to our IntelliJ, we're going to come up here and do at before. Public void, always, very good. Public void, and then I forget what I called that. Ah, come on, where is my mouse? There it is. Set up cat tests. There we go. And so before I can actually create a class, a cat class in here, what I have to do is create a class variable, basically a test class variable up here called myCat. And then I say myCat equals new cat with Bella in there, as well as the age. Because in these tests, I'm going to be testing both the name of the cat, Bella, and the age of the cat, which is 7. So I need to use that other constructor that we initialize all of the class variables, both name and age. So now that being said, I can take this out and consolidate that code. And now we see that my cat turned a little purple there. It's because it's the class variable now. But again, as a personal preference, I always like to put this in front of all my class variables, just because I have made many mistakes in the past and I like putting them there. Perfect. But the true test is that do these tests pass? Guys, I seriously had so many puns about tests, like using test in a sentence, and also because we're talking, oh gosh, it was bad. Like I really did have to restrain myself from adding a lot of those. All right, 3 tests are passing, perfect. We have now we've now removed 3 lines of code to build, of course, another 3 lines of code. But when we have 100 tests coming in here all about our cat, now we don't have to create that cat object every single time, which does save us time in the end. So any questions about this before tag?
Okay.
Yeah.
You declared cat, my cat. When we've created new instances, we've had cat, my cat on line 15. Is that required to do a separate, to declare my cat separately?
So are you saying, was it originally like this, you said?
Yeah.
So we did those in tests. These below are tests. That's where we originally did this.
Okay.
This here is not a test.
Okay.
That's the biggest thing, is that we are doing this inside of a before method, not a test method. A before method is not a test. Do not try to test anything inside of a before method. What it does is it constructs or gets things ready inside of this class, this cat tests class, to do the tests. It's kind of like prepping the kitchen before you actually cook something.
So it is required to have cat my cat outside.
If you want to use the before tag like this, because otherwise these tests down here can't access cat my cat.
Okay. Okay.
If I put this here, then all of these people down here will be like, where did you take my cat? Why did you take my cat away?
Okay.
That's why we have to do that.
Does the before method only exist in a testing environment?
Yes. It is a JUnit specific annotation, to be very technical. Great questions here. Anybody else? All right, let's hop back. So we always have to make sure to clean up ourselves. We've been told our entire lives we have to clean up after ourselves. So same with tests, we have to clean up after ourselves. Looking at the before, say this time, for whatever reason, we're gonna bring in that scanner. Everyone remembers scanner, it's not going anywhere. But one thing about scanner we should also remember is that we always need to close it when we're done with it. We need to tidy it up. Well, say you bring a scanner into your test. How are you going to close it? How are you going to clean up after it? Well, the answer with that is using the after annotation. This method will be ran when all the tests are finished running. In this case, this is where we'd want to close that scanner. So let's see this in action as well. We're not going to see too much here, but we're going to say scanner and scanner. Wow. Yeah. Import class. Thank you. Is that scanner equals new scanner? Of course, system.in. There we go. So we created our scanner, and now at the very bottom, we're going to put after. You don't have to put after at the very bottom if you don't want to. You can put it anywhere really, but it's just good practice to put it at the very bottom. Kind of keep it in like a timeline kind of format. Down class. In this case, I do this.scanner.close. And there we go. Now we're closing up that scanner. We're tidying up. So this is how an after would work. When all those tests have been completed running, this method will get executed to clean up our scanner. Let's make sure all this still works. And any questions about that?
Why do you need a scanner in there?
It was just for an example. You don't need a scanner at all. I was trying to think of something I have to tidy up with in this example, since scanner was the easiest one to think about. So you don't actually need it. It was just to show you that this is how you would tear something down if you ever did need a scanner or something else in your test. Yeah, good question, Kim.
Is it necessary to always have after in all the programs?
No, not at all. In this case, I wouldn't need an after if I took out scanner. Well, what was that? Like Kim said, you don't actually need scanner in this test. I just did it for an example.
Okay.
I don't need an after here. After is optional, and so is before. Before is also optional.
Okay. Thank you.
Yeah, absolutely.
Why do you have to close a scanner?
Scanners should always be closed after they're done being used. If you don't close a scanner, bad things will happen. Those bad things are called memory leaks. We're not going to go into what memory leaks are, but we always need to make sure if you're using a scanner, you close it at the very end of it.
Okay, thank you.
Absolutely.
On that in any of our practice, I think we've never closed a scanner before.
Adam, I'm sorry, was that a question? What was it?
Why? So why have we not had to close a scanner before in our work?
So it is highly recommended to close them. It's not going to be forced upon you by the scanner class to do that. It's kind of like we have to remember to do that. You might see it missing sometimes from code. That's fine. It is, again, highly recommended to close it at the end of your code, but you don't have to. In the applications that we're working with, it's not going to be that big of a deal if we forget a close here and there. We're talking about massive applications through banking or financial systems or something like that, that if you have thousands of scanners open and you're not closing any of them, bad things will happen then.
Gotcha. Thank you.
Yeah,
Can you give-
absolutely.
Can you give us examples of other kinds of things that we would have to like close or tidy up?
Yeah, think of things you have to close as when you're opening the door to input. If you open the door for a user, for another computer to give you information, an API, you're reading from a file, things that are taking in a lot of information, those kinds of, they'll call them streams, scanners, or APIs. Those kinds of things with that kind of functionality, that's when you're gonna have to close stuff. You gotta close that door at the very end because you don't want any more input. Basically, you wanna keep your home very tidy and safe. So open the door to let information in, but when you're done taking in that information, you need to close that door. Does that answer your question, hopefully?
Yes,
We haven't
thank
gotten
you.
into a lot of that. Okay, we haven't got into a lot of that, so hopefully I didn't scare anybody. But yeah, taking in information needs to be closed. So Curtis, you'd actually create, if say I wanted to try 2 cats or something like that, my second cat, you would actually do it all in the same before tag. Rob, that'd be my cat's name. I feel like a cat sometimes I would own would just be called Rob. It's gonna be 3. So you'd create the second instance inside of your before tag. What if you wanted to create a dog for whatever reason? Same thing, you'd add it in the before tag. Do all of your initialization all within a single before tag. And then, Frank, I see that you're typing. Did you want to feel free to shout out your question too if you'd like.
In this case, would you have to have a separate test to test the names of the second cat?
It would be best practice to do that. You want to keep your separation of tests as much as possible, separation of concerns of your tests as much as possible. So it would be in best practice, yes, to do a second test.
Would it even be necessary since the first test, since it works on the first cat?
Technically, you're very correct. Yeah, we've already tested the cat class, so yes, it would work on the second cat. So yeah, okay. it would not be necessary.
I have one more question.
For sure. Give me 1 second. Sorry, Frank just asked a question there. Frank, yes, it would be null. If you didn't pass it in, if you use this constructor up here, if you didn't pass in an age here, yes. Age would be null because we never assigned it to anything. Awesome. And then I'm sorry for cutting you off. Go ahead.
Well, that's okay. I was asking, like, before helps to, I think I missed that, like that annotation before helps to load that information and makes the test run faster, like how it helps. Anyways, it was loading before also, like before we put this before public void, like this code.
Yeah, absolutely. So it saves us the one of the main reasons why we do this is it saves the developer time from creating a new cat in every single test.
Mm-hmm.
And that's really it. So it'll save us time. It will also help out with configurations as well. Yes. But in the end, it will save the developer. It will save you as the developer time. Otherwise, you'd have to create a cat every single test. And if you have 100 tests, that's 100 unnecessary lines that you've written, which in the end does add up to a significant amount of time. It also keeps your test more simplistic. Tests will become increasingly more complex as you get into the technology industry. So using that before tag kind of helps, 1, optimize, and 2, remove that unnecessary code to keep it looking more clean. We want to make sure our code stays very clean. So it's good to do that.
Thank you. That answers my question.
Great. Awesome. Absolutely. Let me go ahead and do an assert true and assert false. Why did I just do that? Wow, I am having a case on Mondays. Okay. Real quick on an assert true. Say we have in here I don't even know what a Boolean would be for a cat. Someone give me a Boolean cat class value. Anybody?
Loves milk?
Is carnivore. Loves milk. There we go. Loves milk. Perfect. All right.
Alive.
So we have this loves milk. What I'm going to do up here is create a private Boolean loves milk. All right. This loves milk. I love this. This is hilarious. Loves milk. There we go. Save that. And now we're going to do a getter for that loves milk. Public Boolean get loves milk. This dot loves milk. There we go. Save that. Car tests. Cat tests. I keep seeing car for some reason. I'm going to add another test down here. Cat loves milk. Returns true. There we go. All right. So up here, I'm now going to, so what I'm going to, actually, we're going to do a cool thing here. We have two instances, my cat and my second cat. Up here, I'm going to say this one loves milk, and this one does not love milk. So down here, my cat dot get loves milk should return true. These should both be Booleans. Well, I'm going to take this one out because we don't need it. It's a very simple thing. Very simple value. So actual, and it should be true. So this is how you'd write a true assert with the value true here. But again, developers want to save as much time as possible. So if we just have true here, what we can do instead of assert equals is just put assert true and just put in our actual. This saves us just one parameter. So this is how we'd write an assert true. It just simplifies the assert equals just a bit more. And we can run this. Perfect. Perfect. Get it? It's cats. Perfect. All right, and this one's going to return false. Tell me, which cat would return false if I checked if it loves milk?
The second cat.
Very good. The second cat. So in this one, instead of assert true, I'm going to put what?
Assert false.
Very good. Run that one. Perfect. So what assert true and assert false do, just taking it down to their bare bones, is it just checks if our actual value is compared to true or compared to false. Of course, always depending on if you're using assert true or assert false. Daria, does that answer your question?
Yes, it does. Thank you.
Absolutely. All right, anybody else got a question about beautiful, beautiful unit testing?
I have a quick question.
Yeah, what's up?
Sorry. If you wouldn't mind scrolling back up, this should be real quick. When you put in the before portion, what would you call that? Would you call that a method? I'm not sure. But my question is, you created variables for cat, my cat. Was that just so that we could then reference them in each of the tests? And then did you wait to initialize them in the before section because that's more of a constructor?
Yes, you should initialize your information always in the before tag.
Okay.
Sorry, that's with a small caveat. You should always initialize the information in your before tag that will be used in multiple tests.
Okay.
So if my cat was only used in one test, only one test, I would not want to put in the before tag. This is if it's used in multiple tests is when we want to put in the before.
Okay.
Yeah, but regardless, yeah, this is where you'll want to initialize your information. Don't try to initialize it up here. It's best practice to do it in the at before.
Okay, thank you.
Absolutely. Great questions, great questions. Anything else?
Got a quick one.
Yeah.
When this scales up and you have multiple classes, like we have the dog class, then each of those would have its own test page, right? Its own test class.
Absolutely. As we show in this example, it's called cat tests. What we did here to name this was start out with the specific class we're going to test, cat. If I created a dog class in this instance, I would create a completely new class file called dog tests.
It's kind of like spec in JS, right?
Absolutely. Yeah, we want to keep our tests separate so we know what's going on. It's more for our sanity, if anything. You know, one class with like all the tests ever for an application would, well, that would be a bad Monday. All right, anything else? You guys all taking coffee. Everyone's asking questions at the very end. Thank you. Someone got sugar. It's great. All right. Well, in that case, everybody, we're done. Happy Monday. We have completely finished this exercise, or this unit testing stuff.
You have now another fin shed, you know. You're doing that on purpose.
Oh, yeah. I embrace it now. I completely embrace it.
That's awesome. Okay. Thanks, Kyle.
Absolutely. All right. Let's see. Going through this. Anything? That's funny. I saw there was some talk about dogs being carnivores or omnivores. They are omnivores, I think they are, right? I didn't exactly see what the census was of the conversation, but all right. Well, everybody. So, last thing I wanted to point out too in here. One of your colleagues also pointed out something to me, because in my videos I'll type out system.out.println like directly out every single time. If you don't want to do that, you are always welcome to use the IntelliJ hotkeys, which is S out, and then just pressing enter or tab will create that system out for you. There's also a few other ones in there as well. Let's see, S. So if you do like S, I don't actually know what some of these are. Yeah.
If you do PSVM a tab, it'll do the main method. PSV, yeah.
Oh, VM.
Mm-hmm.
Maybe I don't get that. Oh, probably because I'm not in the PSVM. Oh, neat. Yeah, see, look at that.
Awesome.
IntelliJ does help you sometimes. And then finally, we are on to what, the 5th lecture here. So I asked in the very beginning of class if anyone's liking Java. I know there are some growing pains and frustration with learning this new language. So just know every single time you look at something and you do feel frustrated, it's not necessarily that you're not understanding it, it's that your brain is quickly learning the material or getting to the point where it can make connections. That's what that pain, that frustration is. So stick through it, stick with it, and always reach out if you have any questions. But you all are doing great. Hearing just feedback from TAs and everything, it sounds like people are really getting through the material. So I do hope you guys are starting to enjoy Java as we work further into it and using these technologies. So awesome job. That's all I have for everybody tonight. Does anyone have any final questions before I stop yammering?
I was just wondering if you could show the tests again, the code.
Yeah, so what I'm actually going to do, how about this? I'm going to probably push that out to GitHub so everyone can just bring it onto their machine and see exactly what we did. Would that help you out more?
Yes, that works well.
Okay. Yeah, I'll definitely share that package online. Yeah, for sure. All right, everybody. Well, again, thank you very much for all of the input, questions, and participation tonight. I hope you guys all did get some things out of for unit testing for tonight. enjoy the studio. It's a great one. And then other than that, that is all I have for you. Thursday is Inheritance. Get ready for that. That's gonna be a lot of fun. Oh, that's gonna be really fun. Yeah, it's super cool. So hope you guys will like that one too. But that's all I got. So thanks again. Stick with it. Keep working hard. You're all doing great. Keep smiles on and drink more coffee.
Thank you.
It saves lives.
Thanks, Kyle. Have a good one.
All right, bye everybody.
Bye-bye.
Thank you.
Thanks, Kyle. Good night.
Bye everybody.